All right, I guess it's a good time to talk about fairness. Um, so today, Alan Chan, a master student at RLA, will tell us about fair ML, in particular problems in fair ML.
All right. So yes, my name is Alan. I'm currently a master's student, going to be defending soon, and then I'll be a PhD student at Vila. But just because I'm in Montreal doesn't mean we can't be friends. So, if you have anything you want to discuss, feel free to reach out. And as Abhishek said, I'm going to be talking about fairness and some problems I've come across with, I guess, the fairness literature as I've been reading through it. So let's get started. The high level goal of this talk is really just to spark discussion and to encourage us all to be a little bit more critical of when people claim that their algorithms are quote unquote fair, which definitely a lot more people are trying to do that, especially with recent events. Now, what sort of recent events am I talking about? Well, of course, in the academic world, a lot more research papers have come out in recent years on fair ML. There's even like a whole conference devoted to fair machine learning now. Um, there's a fair machine learning textbook as well. And at the same time, as more machine learning algorithms are being applied to the real world, we're really starting to see a lot of perhaps unintended consequences of these algorithms. So I'm sure you all remember when Google Photos classified some black man as like a gorilla. There was the compass recidivism algorithm, which was alleged to be more likely to classify black men as more likely to recommit crimes after release. And there's also like HireVue as an example, which is this company that uses machine learning to analyze videos of applicants for a job and rank them based on certain metrics. So as we're applying these machine learning algorithms to the real world, we're starting to see how machine learning is starting to reinforce and magnify a lot of the biases already present in society. Now, before I get any further into this talk, I just want to make clear my position generally so that there's no misunderstanding throughout the presentation. So firstly, I think that machine learning can't and probably shouldn't be used to solve all problems. When you look at something as complicated as climate change or criminal justice reform, what is the solution that's going to get us out of that? Well, it's going to be really complicated, talking to all the stakeholders involved, making sure that we distribute power in the correct way, coming up with actually good policies. It's pretty clear that, sitting in your chair, writing some code isn't going to solve all these problems. In fact, a lot of the time, I think machine learning can make things a lot worse. For example, when you apply an algorithm to predict recidivism, that's going to depend on data where Black people and Indigenous peoples in particular are already overrepresented in the criminal justice system. That being said, I don't think that the harms of applying machine learning are always going to outweigh the benefits, and that's why it's still important, I think, to think about applying machine learning to the real world and using it to help improve what we're doing. An interesting example of this I found recently was the AI Economist. I'm sure some of you might have heard. There's sort of a discussion on the Slack channel. And essentially what it was Richard Soch's group had this reinforcement learning agent come up with a tax policy that, according to the admittedly simple experiments in their environment, resulted in outcomes that were more equitable and more efficient, again, according to their own metrics. So definitely, I'm not saying let's go out and apply this AI economist to the real world. I think that's kind of ridiculous given the simplicity of the environment. But using machine learning can really help us to design mechanisms to help us create a more fair world in some cases. Of course, we have to be careful. All right. So with that in mind, let's talk about fairness and machine learning. Now, because this is only a 20-minute talk, a lot of what I'm going to say is certainly a simplification. Fair machine learning is quite a diverse field, and indeed, there are a lot of people doing work in addressing a lot of the problems that I'm going to be talking about in this talk. So if you're interested in, getting the terms around what people are actually doing, we can have a chat afterwards. But for the purposes of the talk, this is going to be what fairness in machine learning is. So we're usually interested in something called a decision. For simplicity, you can think of this as a binary variable. So whether you're hiring somebody or not, whether you're giving somebody a loan or not. The second thing we're interested in is something called a protected attribute. So this is something that you kind of don't want to discriminate against. So this could be something like gender, like sexuality, or race. So ideally, you wouldn't want to discriminate against Black people when you're hiring, for instance. The last thing we're interested in is just like a catch-all bag of features X. So X essentially just represents, what other things can we use to make the decision D? So if you're hiring somebody and race is a protected attribute, you don't want to use race explicitly when you're hiring somebody. These other features might be, education, it might be work experience, it might be, reference letters, that sort of thing. So with these three things in mind, what is fairness in machine learning? So there are a variety of definitions. I'm going to use, I think, probably the most understandable one for this presentation. And this is going to be the only equation of this presentation. So essentially what fairness in machine learning, a lot of it is saying the probability that I hire somebody, that shouldn't depend at all on the protected attribute. So the probability of me hiring somebody shouldn't depend on A, it should only depend on X. And that's why A drops off when you do the conditional probability. So there are a lot of problems with this definition, some that I won't really go into, but you can sort of think of this as saying fairness means that we don't take into account these attributes that are quote unquote protected. We only take into account what's quote unquote relevant. So that's the definition that we're going to work with for this talk. Now, what are some examples of this? An example is loans. So, when you give out a loan, you don't want your positive loan decision to be dependent upon race, because that's discriminatory. Another example is medical treatment advice, right? So if you had some sort of machine learning algorithm to help suggest courses of medical treatment, you wouldn't want the treatment to depend upon like the economic class of the patient, right? So on how willing they are, how able they are to pay. Lastly, maybe a more benign example is in network routing. So when you're doing network routing, you want to make sure that one client just doesn't monopolize like the entire network and all the traffic, right? You sort of want it so that everybody gets a fair shot at getting their data through the network. All right, so now I'm going to talk about three aspects of the paradigm of fair machine learning that I introduced. And the rest of this talk is just going to be going through specific problems with those three aspects. Okay, so the first aspect is that predominantly, with some notable exceptions that I can talk about later, fair machine learning is conceptualized in terms of supervised learning. So you have a fixed data set, you learn a classifier to predict the hiring with as much accuracy and as much fairness as possible to satisfy the definition I gave. But otherwise, you don't try to model the world. You don't look at the long-term consequences of your actions like you do in, say, reinforcement learning. Secondly, fair machine learning predominantly so far is about ignoring protected attributes. So you saw this in the definition I gave earlier, where you want to make sure that when you apply your decision, the decision doesn't depend at all on the protected attributes. This is kind of a problem in some cases, not in all cases, which I'll talk about later. And the last problem is that an analysis of power is omitted from fair machine learning. So nowhere in the definition of fair machine learning or of a fair machine learning algorithm that I gave is there any reference to the relative power of the stakeholders involved in the particular task. In fact, like in the definition itself, there is no reference to the overlying task either. Any task that fit that definition was quote unquote fair. Okay, so now we're going to talk about what else is missing. And I'm going to try to do this through some relatively simple scenarios to try to tease out what really might be missing from a definition of fairness in machine learning. Now, when I say fairness, and definitely this is like my personal view, when I say fairness, what that really means to me is some notion of justice or or equality. So when we're trying to certify something as fair, what I'm really interested in is, does this policy or system or algorithm make sure that we have a more equitable society? And that's sort of going to be the guiding principle when we go through these scenarios. All right, so scenario one, the problem of supervised learning. So the fact of the matter is that a lot of groups, in particular racialized groups, are underrepresented in positions of power. So for example, in politics, in newsrooms, on corporate boards, in academia. And I'm sure a lot of you have been hearing more about this recently. Now, more representative hiring, so more diverse hiring, and specifically targeting people from underrepresented groups, definitely benefits the people who are hired, right? That's one reason why we do want to have a more diverse board, because we want people to have equal opportunity to share in the profits of the society we've created. Now, the important thing to note, though, is that that's not the only effect of having more diverse hiring. Another really important thing to note is that there are a lot of downstream effects from more diverse representation, no matter what you look at. A great example is the role model effect, right? So if you see somebody who shares your identity in a position of power, you're more likely to think that that's something attainable for you, and that's something like for you to achieve, right? And that's why it's so important to have diverse representation. Another positive downstream effect is just having better policies, right? So if the people in government have are more likely to share your identity, they're probably going to understand your particular experience more and be able to craft policies that better suit your lived experience. So the upshot of this is that fairness is a long-term thing. And I imagine this isn't really a controversial, surprising thing to a lot of people here, especially when we're doing reinforcement learning, right? When we're always thinking about the long-term consequences of our actions. But unfortunately, the fact of the matter is that a lot of the time, the long-term nature of fairness and what you do, how that affects the distribution of burdens and benefits in the future, that's not something accounted for in a lot of fairness definitions. All right, number two, scenario two. We're going to talk about the exclusion of protected attributes. Okay, so let's think about the board exam. Let's think about the underrepresentation example. So affirmative action, so essentially explicitly targeting specific groups and hiring them into particular positions or giving them particular positions of power, or even having quotas. So affirmative action can help to redress a lot of the harms of not having diverse representation and prevent future harms. Now, the thing about affirmative action, though, is that it explicitly uses the protected attributes. It doesn't ignore race. In fact, it targets race, for example, or gender specifically. So under our definition of fairness from earlier, any machine learning algorithm that tried to enact affirmative action would be unfair because it explicitly would use the protected attribute. Now, there might be a possible objection to affirmative action style policies, right? Like the objection might be it's discriminatory because you're targeting somebody of a particular identity. And really the society we want to create is where, it doesn't matter what identity you have. So my response to this objection is that there's this important difference between formal equality and substantive equality. Formal equality, you can sort of think about it as equality just in law, right? So we all have, equal voting rights. We all have equal freedom we all have the freedom of speech, right? We all have equal protection under the law guaranteed by the Constitution. But unfortunately, having formal equality a lot of the time doesn't actually guarantee equality in terms of the lived experiences of people, which is more to do with what's called substantive equality. So more doing with what's actually happening on the ground. And when you look at what's happening on the ground, so for example, child poverty rates for Indigenous children, it's clear that despite formal equality guarantees, there really isn't substantive equality a lot of the time for a lot of people. There's no law specifically saying, Indigenous children have to have higher child poverty. It's the result of a lot of structural factors of colonialism and imperialism. So because there are groups of people who do not have substantive equality with other groups of people, that justifies specific policies targeted at these people to make sure that they do live equality. I'm also going to note that affirmative action is covered and protected by the Charter of Rights and Freedoms under the Constitution of Canada. So section 1 of paragraph 1 of section 15 here is equal protection under the law. Paragraph 2 explicitly protects affirmative action by saying that at no point should you read the first paragraph as saying that affirmative action is unconstitutional. To a lesser, this is to a lesser extent true in the United States. So I guess this is the benefit of having a modern constitutional document. This is from 1982. All right. So in any case, the upshot is that fairness isn't just about formal equality. It's about substantive equality. And often, to be able to make decisions more fair, we're going to have to take into account the protected attribute of the protected class. Although this might not always be the case. Of course, this has to be contextual. All right, moving into our final scenario now, we're going to be talking about power. So suppose that some company, I'm sure you all have a favorite company, in mind. Suppose some company develops completely fair facial recognition technology. Okay, so it's 100% accuracy, always classifies the person as like the actual person. Suppose we have this mythical technology, right? Now, the reason I put fair in scare quotes is that, who chooses that definition of fairness? That's something that, is quite important because for a variety of reasons. One reason is that in practice, you're never going to be able to ideally satisfy some definition of fairness, just given the fact that you're always going to have like some testing error. So who is going to be responsible for making the sort of trade-offs between like fairness and accuracy, right? It's also a known result that a lot of definitions of fairness in machine learning are mutually unsatisfiable, meaning that except in very special certain cases, you can't satisfy like definition A and definition B at the same time. You're going to have to make that choice between those definitions of fairness. Who is responsible for making that choice? That's an important decision, I think, when certifying whether an algorithm is fair. So the point of all of this is just to say that fairness involves power. It's more than just looking at the decision at hand and saying whether you discriminated against a particular group or not. It's also about who gets the decision-making power to come up with a definition of fairness and who has the power to challenge that definition of fairness. So in a lot of cases, I think we do have to step outside of the realm of machine learning to ask and answer these questions. So those are the 3 scenarios. So just to summarize, if I lost you at any point, talked about 3 very important things. So the first is that when we're talking about fairness, we have to be concerned with the long-term consequences of fairness. It might actually be that in trying to create a society that is more fair, we're going to have to make decisions right now that may be unfair for some people in the short term. Unfair in the sense of not. So I guess an example of it might be affirmative action again, right? When you quote unquote like discriminate against certain people by targeting them to give them more opportunity. The second thing is that fairness should also be focused on substantive equality rather than just formal equality. So in a lot of cases, you might actually want to look at the protected attribute. And finally, you also want to think about who has power when you're thinking about fairness. So that's it. I have some closing questions for us to discuss. I also have some like works I've found really interesting and helpful in my perusal of the fairness literature. I'll put the slides up afterwards so that you all can, look at those sources if you're interested. Thank you.
So do you have any answers to these questions?
No, but in particular, the second question I think is really interesting. There's this line of work in trying to include fairness So first in like 2017, they tried to include a notion of fairness in the bandit setting, and just recently, I think at ICLR, there's this paper on some benchmarks for fairness in like the reinforcement learning setting. And there's also this other parallel line of work of people trying to include causality in analysis of fairness. I think overall still pretty immature lines of work. I'm definitely also not an expert in causality.
Yeah.
Are there any sort of work on kind of like recognizing if some an organization is being unfair, like on purpose? So I don't know, like maybe you may think that like, and when it comes to like gender and race and those things, maybe like there is not that much of an incentive on like an organization being discriminatory. It's usually something that like happens by accident at this point, or like because of the problems in machine learning models they use. But then when it comes to some other things, companies might have incentives to actually enforce like this kinds of discrimination. So for example, in my case, like something that's kind of related to me is that, for example, like some university applications or like job applications usually ask you about your nationality, or like ask you if you're a national of, like, for example, Iran and Cuba, those countries. And when you answer yes, or when you say you're from these countries, then like they realize you're gonna have a lot of legal problems in this country and a lot of extra documents and certificates that you're gonna get. Or if you're out of this country, you're gonna have a lot of trouble getting visa and getting this country and those things. Now, I'm wondering if there's kind of like, I don't know, a sort of fraud detection work to catch these things. There might be some laws to like keep them from explicitly discriminate against based on nationality, but they may do it like without like explicitly saying this. So like when you talk to people, like you'll see like when they say like, when you talk to people, like you compare like Iranians with like some skills and like non-Iranians with some skills, you'll see that like they're usually like very easily rejected, or like they get rejection emails so soon that you will realize it's most probably like an auto reject or something. So like I'm thinking of, is there kind of like fraud detection works for this kind to catch this behavior?
Yeah, thank you for sharing that. And definitely a pretty shitty situation. Unfortunately, I don't think there is a sort of like, I guess, unfairness or unethical detector. I think that's really right now up to the job of researchers like us to study and understand systems that are put into practice. I think there's also this, you bring up a good point. There's this like dangerous sort of incentive to do unfair things, and also to be seen as fair, when you're doing those unfair things. With the rise of all these like quote unquote fair algorithms, there's a lot of danger of like fair washing, where when you call an algorithm fair, suddenly you become much less careful in actually checking whether that algorithm has fair outcomes or not. Yeah, that definitely doesn't answer your question. I don't think there is, unfortunately, but I don't know.
Hey, oh, sorry. Go ahead.
Sorry, I don't have my video on because I'm in the basement hiding from the heat, so you might not see me. So thanks for your talk. It's very motivating and thought-provoking. I had a question. Well, I had a comment, I guess, not a question.
Sure.
I wanted your comment on my comment. You said something about aspects. You listed 3 aspects of machine learning, and the first one was supervised learning. And I want to tie that into your... Oh, you don't have to go back, but I wanted to tie that into your last slide. So now you need to go back.
Okay, sorry.
And the second point in your last slide about reinforcement learning. And I'm wondering if what you think of as an aspect of fair machine learning being supervised learning is really just because this is one of the most applied methods out there in real life and practical problems, and that's why people have maybe seen impacts on fairness from it. And for instance, if you take the example of loan applications, and if you were to use a supervised learning method for it, and you would see, I guess, if there was nothing done to mitigate bias, and if the data was biased, you would see effects of bias in your outcomes. That doesn't necessarily mean that it won't happen in other things, right? Like, let's say reinforcement learning. Now, I'm not advocating that anybody use reinforcement learning for this, but if someone were to use reinforcement learning for something like loan applications, it would really depend on how large your environment is or how large your state space is, right? Like, if you were to only consider a community which is in a lower socioeconomic class, you might learn certain things that connect features with, whether you should or should not give a loan. And then if you were to apply that in a different community, you might make errors in fairness because you've learned something about features that was really not relevant to the question, right? So I'm wondering if you come across anything in your readings about this, about how you mentioned something about bandits in fairness. I don't know which paper you're talking about, but I personally don't like it when people just take a new concept and then apply it to everything. Now let's see what fairness looks like in bandits. Let's see what fairness looks like in this. Unless there's a real problem that emerged where you want it to look at fairness. So I wonder if you saw any practical situations where fairness tied to these other methods like reinforcement learning or bandits arose.
Yeah, thanks for your comment. And like, I totally agree. Like, I don't think, applying reinforcement learning is going to solve a lot of problems. I think with the current state of reinforcement learning, it might like cause more problems. Also, I wanted to comment on you mentioned like what I think you were referring to with one of your comments was this idea that even if you don't explicitly use a protected attribute, a lot of other features might be correlated with that protected attribute. So, for example, in Canada, the United States, because of the history of redlining, location is actually very much correlated to race, because Black people were denied mortgages to live in better areas. So that's like I think a problem that like both reinforcement learning and supervised learning would face. As for the last part of your question on whether like reinforcement learning can help, or I guess like papers I've come across, I'm definitely not sure. So far, it doesn't seem to me that there is like a quote unquote like killer sort of application. The really only work I found on reinforcement learning and fairness was this sort of like benchmark where they tested a lot of current fairness algorithms in the literature, and they looked at sort of the long-term outcomes of these algorithms, and a lot of them seem to be unintuitively to have unfair outcomes in the future, even though they're trying to guarantee fairness in the short term. This other paper, I think, I don't quite remember, but I think it was trying to guarantee fairness in terms of the final return, which is a very abstract idea. It's hard to see how it might be applicable in like all circumstances. Does that answer your comment, or?
Yeah, well, I guess I wasn't really looking for an answer, but just a discussion on it. In terms of outcomes and fairness, you started out with one definition of fairness that you decided to use throughout the talk, but there are other definitions of fairness that people have used depending on the circumstance. Yeah, I just wanted to put that out there.
Yeah, certainly.
Yeah, and Eric has a great comment about the particular definition that we were talking about in the chat. So I can read it out. He's saying that there's no accounting for correlation between the protected attributes A and the other features X, but the protected attributes are 100% going to affect the other features. So example, lack of access to the best tutoring resources due to socioeconomic status, resulting in a lower GPA or standardized test scores, right? So you can remove one of those things, or things like, your PIN code can decide, has a very high correlation with, let's say, your race or something, right? So calling algorithms that satisfy just this definition seems really damaging.
Yeah, certainly 100% agree. I think I was also talking about the correlation of race with location. Yeah, this is another issue with like definitions of fairness that I didn't really touch on. Yeah, so people are trying to work on ways to get around this. I'm not sure if there's a really convincing way to do so. There's this what's the work called? If you're interested, it's called I think counterfactual fairness that tries to get around this correlation issue. But thank you for your comment. Yeah, it's definitely very, very relevant.
I think, yeah, also something along that lines was, so I guess if you've read this book called The Ethical Algorithm, it brings up this issue of, so it talks a lot about, incorporating fairness and privacy into our algorithms. And one of the things it says is that people can consciously or subconsciously create this something called fairness gerrymandering. So the simple example that was there was, if you account for specific categories of attributes, you might not account for like the intersection of them. So for example, let's say you have to give 20 tickets of something to a group of people, some of which are, so let's say we have race and gender in that. So like black, white, male, female. And so the most fair way is to give like 5 to each subcategory. So like black males, black females, white male, white females. But if you're just focusing on accounting for race and gender, a valid solution is giving 10 tickets to black males and 10 tickets to white females. So you satisfied all the criteria of accounting for those two factors separately, but you didn't account for all the cross intersections between those. So yeah, I think that was an interesting point there.
Yeah, great point. Intersectionality definitely is not accounted for in a lot of works on fairness today, and this is sort of motivation for this other trend in fairness research towards more individualized definitions of fairness rather than group level definitions, because as the number of groups it increases, the sort of cross sections, intersections, like also increases exponentially, right? So it becomes like rapidly infeasible. It was already hard in the first place to satisfy these like sort of unsatisfactory fairness definitions. So when you increase the number of groups, it becomes even harder.
Right. Yeah, I think he proposed that, like at least in the literature, there are these like GAN sort of algorithms, which like they say that, oh, so there's one part of the algorithm which is trying to maximize the accuracy given the constraints of, let's say, each particular criteria that you're given, and there is this adversary who's saying that, okay, but you didn't account for this subcategory. So it figures out some intersection and says that, okay, you have to maximize the accuracy for this too, and so then the generator has to account for that, and so there's like a two-player game going on. And yeah, and I don't know much about that literature, but I think people are thinking about it.
Just to add on to that, like, wouldn't that also solve the power issue? Like, if you are like an underrepresented group and you can make queries to this algorithm that makes decisions that you think might be unfair, then you can query it several times to see like if at some point it's being unfair towards your particular group. So that type of adversarial algorithms in some kind of way would give agency to those groups that don't hold the power to design the main algorithm itself, right? I don't know, I just tested that thought.
Yeah, I think that's one way to address the power issue. I think fundamentally, though, it also comes down to like having, I guess, like diverse groups and marginalized groups in positions of power actually doing the designing rather than like relying on the quote unquote free labor of of these people to make algorithms, but when really like we should be designing better algorithms or thinking about these issues at the get-go.
So is there a way to learn the objective functions from some data? For example, say I look at the Canadian Constitution and I learn an objective function based on the Canadian Constitution, or I look at some group that is considered fair, maybe Norway or some place, and I say, okay, this place is good. Let's figure out what the objective function should be.
I'm not really sure what that would entail, but I guess one immediate difficulty is like, notions of fairness already like pretty contestable and require time to unroll. I mean, that's like one reason why like Canadian and American systems, and I guess the UK as well, depend on case law. It's because like, when you're a legislator, like sitting at a table, and you're like, okay, like equal protection of the law, like what does that actually mean, right? Like as a legislature sitting at this table, you can't roll out every possible scenario and like encode every possible scenario into your constitution. For better or for worse, like we choose to rely on judges who interpret the law over a period of time. So this is just to say that there's a lot of ambiguity in the Constitution, in case law, and it seems difficult to like specify a precise objective.
Thanks.
I have a question kind of along that line. So I'm also thinking from practical perspective, where there's only long-term effects. So any policy that you put out, you don't see the immediate effect, but somehow you have to justify. So in that, if you want to run to see the causal effect, for example, you would have to run something like some sort of randomized trial. That's assuming the effect is kind of minimal, and the group that potentially being affected would agree to that. But in the real world, we all know that it's not often possible. So I just wanted to get your thoughts on that, or maybe you have seen some examples of that.
So about so is your question about how do we actually understand the effects of the policy?
Yeah, because in a way, you don't really see the effect until you did something. But there are many limitations to the decisions you can really make. Right? It's not like in a simulation or something that you can just try anything. So
yeah,
so it's more of a like open-ended thing, right?
Yeah, like that's a great question, and I think like a much more fundamental question for anything we try to do, right? I think like there are sort of two answers here. What that are sort of the same answer, I guess. The first answer is study history, because history in some sense is this like big pot of experiments that people have done, right? And you try to correct for the fact that you don't have a double-blind trial. Maybe you don't have like 100% confidence in your results, but maybe like if people have tried it and it seems good enough in like X amount of circumstances, maybe that is good enough. I guess the second part of the answer is simulation can give us some intuition for if something's going to work, especially in very simple scenarios. Like if something fails in a very simple scenario, then probably it's not going to work in a very complicated scenario either, right? I guess this is why like having some form of decentralization. So for example, in Canada, health policy is decentralized to the provinces. That is good to the extent that it allows diverse experimentation and allows us to see like somewhat independent, results of these policies being applied.
Yeah, I thought about the first approach as well, the history dependent. And I guess in the real world, that would be the main approach to convince people. But we also know that the policy somewhere else might not be fully applicable to this new place or new country per se. So yeah, I think it's pretty hard to You can probably convince the policymaker or people who vote, for example, but you still won't really see the effect until many years later.
Yeah,
so it's
there's just fundamental uncertainty. And I guess sometimes like we just have to try it on a small scale and see if it works.
I guess so.
If it doesn't, like write it down and make sure to remember it doesn't work.
Yeah, thanks.
Hey, Alan. So similar, like kind of on the same page as that Vincent was mentioning there. I thought it was interesting when you mentioned like the simulation of the like smaller economic system, that there was like that project conducted with like a simple environment, and they tried to find the ideal tax brackets in a sense.
Yeah.
So I was kind of wondering how, if you think that has any potential in being used kind of like moving forward, because it seems like a really, it kind of addresses the second point that you maybe meant there about simulating how these fair policies or maybe what the best affirmative action is and what it would actually do in society. So instead of doing that, if we could have like these nice multi-agent environments and kind of roll out and see what happens.
Yeah, thanks for that question. I think definitely it can really help. Like specifically in the case of tax policy, a lot of the literature assumes that agents maximize utility, which allows you to use something called the envelope theorem and make a lot of calculations like very simple. And that's how the sort of quote unquote optimal tax brackets are derived in a lot of cases. But of course, in reality, like agents probably aren't maximizing their utility. At best, they might be like Boltzmann rational with some temperature, right? So there's a lot of uncertainty in the best action. So I think like simulation can serve this really nice middle ground between like what does the theory tell us about what is like the best tax policy, and like in practice maybe we don't want to put in place this tax policy yet. So simulation is like, okay, like in a sort of semi-realistic scenario where you have a lot of agents, they're not really maximizing, or they're not successful in maximizing their utility, but they're at least trying to. What actually happens? And I don't know if you read the paper. It's actually quite an interesting result they found. So one of the leading sort of works on optimal taxation has it so that as you go up the income bracket, the marginal tax rate should go to 0. The intuition for this is that if your marginal tax rate does not go to 0 as you go up the income bracket, then people basically don't have an incentive to work. The people at the top income bracket don't have an incentive to work. But of course, there's been some doubt about this because this argument really only applies as you go up the income bracket on like a person-to-person basis. So like the optimal top tax rate should be 0 for like the top person. So maybe like Jeff Bezos. Although like I think he should be taxed. But in any case, like that's what the theory says. In practice, though, when they ran the AI economist on their simulation, they found that having this sort of very nonlinear schedule actually did better. So according to their metric, of course. So they measured I don't remember the particular measures, but some measure of like the overall productivity of the economy and some measure of like how uniform was the distribution of wealth. And they found that this like pretty nonlinear tax bracket seemed to be better in both respects as compared to that proposal and also current U.S. federal tax brackets. That was a lot, but hope that answered your question.
Yeah, and I guess another point related to that is that you mentioned that they found like these kind of surprising or maybe interesting results. And even if they aren't maybe as reliable because there was only like a very small amount of agents and a very simple environment, I think it's interesting that it makes you like kind of think that maybe this idea or this sort of tax bracket that you might have never imagined would be actually good, could be good. And so I was wondering for similar things if it could maybe like bring new ways of thinking about solutions.
Yeah, there's this field called social mechanism design or something, which is about I think it's much broader than just applying AI, but in general applying computational tools to help us develop better such policies or mechanisms.
Thanks.
I had a question. So, at what stage should I start caring about the fairness of my algorithm? Say, I'm just working on various reduction of some method. So, fairness doesn't seem to apply there, right? Maybe it's not even applicable until I go to application. So, at what point should I start thinking about it, or
sorry,
what
could
should I know
you
about
say that first part again? I think for me, you cut out a little bit.
So say I'm designing an algorithm that reduces